Now, when we can, we'd like to show you some math that comes from the real world. So today, to start things off, we're going to take you to the horse races. So if you live in San Diego County, you're lucky to live near one of the most beautiful racetracks in the country, at the Del Mar Fairgrounds. So there's a lot you can do at the races. I go myself sometimes. It's a beautiful place to watch the horses, and people watching is fun. But of course, you can also bet on the horses if you like. So what I was going to show you today is a little bit about all those numbers you see on the tote board. The tote board is what they call the display. It has all the horses listed and it has all these numbers that change all the time. And this affects, of course, if you do decide to bet, how you would get paid if you won. So what I was going to do is show you a little bit of the math behind there. In fact, I went to the horse races myself and I took a picture of that board. So I put a copy of the picture on my math cam here. I'll show you the picture. And what I wanted to do was try and explain a little bit about all these numbers. I'll zoom in it on a second, but these are all the horses that were racing. This particular race was 7 horses, so you see 7 listings here. And I'll zoom in a little bit so you can read this. We'll look at the first horse here. If you look at the board there, it says win, place, or show. Those are the 3 easiest bets you can do on a horse. That just means first, second, or third place. And the bottom it says the morning line. Well, the morning line is what the experts predict the probability of a horse winning the race. And the probability is given in these odds. So this odds is 4 to 5 right here. Now these change because the horse track is a very interesting betting environment. It's different than a casino in Las Vegas and playing, for instance, blackjack or something. And the difference is if you win or lose a bet at the horse track, it doesn't come out of the company's money. You are simply betting amongst each other. So any winnings you make came from other people who bet and lost. The horse track makes its money by taking a little commission on everyone's bet. So you know what? They don't really care who wins or loses. They make money either way. So I'll show you a little of the math in a minute about behind that and how you can see how much money they might actually make from a race. But also involved in here is, of course, odds, which we call them, and that's related to probability. There's a little mathematical formula we can convert between the two. Now I should explain a little bit here because the odds here, normally you talk about odds in kind of a loose sense. You might say, you know, what are the odds that, you know, someone gets struck by lightning, or what are the odds I'll win the lottery? Well, you can compute the odds that you're winning the lottery. I mean, the numbers are all set. There's only so many ways you can pick numbers, and one winner is chosen. So something like the horse races, well, you know, it depends on the horse, and you can't really tell. But these odds are compiled from the betting themselves. So yes, the experts say, you know, okay, well, here's what we predict. But the odds change. And in fact, if you go to the horse races and watch the board, the numbers continually change right up till the race starts. So when I took this picture, this was 1 minute before this particular race started. And you can see the morning line at the bottom predicted 4 to 5 odds. But when actually the race was almost ready to start, they were listing it as 1 to 2. Now this could actually change, you know, in the minute I have remaining. The final odds won't be, well, it probably won't be done until the horse race has actually already started, actually. They have computer systems monitoring all the money that gets bet, and then they compute out, you know, what the odds are. Now the odds listed here are the odds of how you will get paid if you win. They aren't really the odds of the horse winning. But they are done, they're computed by how people bet. So the more people bet for a certain horse, the more likely the odds say that horse would win, and consequently, the less money you would win on a bet if you bet on that horse, because it's considered an easy bet. So for example, look at the first horse we have here. The odds 1 to 2. Normally with mathematical odds, you would see the winning chances first and then the losing, but they do the opposite on the horse races. So that means this horse, according to how people bet, is considered a 1 loss versus 2 win horse. So if that horse ran 3 races with all these same competitors, the prediction would be he would win 2 of them and lose 1. I said he, actually I don't know the gender of the horse, it could be a female horse, but the horse would win 2 and lose 1. So those are pretty good odds for this horse. It's favored to win, so consequently it wouldn't pay as much, but these odds control how much you get paid as well. So what this would say is, if you bet $2 here, you would win an extra $1 back, so you would actually get $3 in return, an extra $1. Now compare that to the second horse. The second horse, you probably can't see that in the first one there's a faint little slash between the 1 and the 2. It's not here on the second one. The second one just says 16. That means, according to how people bet, this horse is given odds of 16 to 1. That means 16 losing votes versus 1 winning vote. So the way you would interpret that is if this horse ran 17 identical races, we would predict it would only win 1. At least that's what the odds, strictly interpreted, would say. What they're really doing here is controlling the betting. So if you bet $1 on this horse and it won, they would owe you $16. So you would get actually paid $17 in total to get your $16 winnings. So that one pays a lot more, obviously, because it's not considered likely to win. Part of the fun of the horse races, of course, is you never know, and sometimes these horses do win. And so you have a few people that are very excited and some that are a little upset. But what I was going to show you was how you can mathematically turn these odds into probabilities. This is a standard, a little formula we can use. And then I'll show you a little bit about an unusual way they add up that doesn't quite fit what should mathematically, but of course, there's a reason behind it. So what I've done is I have written down the odds when I took this picture of all 7 horses. So this is 1 minute before the race started. I'll show you what these odds are, and then we're going to talk about how you could easily convert these to probabilities mathematically, and then we're going to see what they add up to. See if I can explain a little bit about what's going on at the horse races. Okay, so I have these numbers on my math cam. I'm going to zoom out a little bit so you can see them all. This is, I've just summarized, these are right off my picture. So these are the 7 horses and the odds that are posted. So how do you turn odds into a probability? Well, for example, look at that first horse, the one we talked about. The odds were 1 to 2. So if you look at these odds, I'll use a dash. Sometimes you'll see a colon or even a fraction with odds. The first number is the number of races he would lose out of 3, and the second one is how many the horse is predicted to win if you interpret these as mathematical odds. So odds always compares a winning to a losing number. So for example, if you were flipping a coin, which is 50-50 chances, the odds would be 1 to 1. 1 lose versus 1 win. Well, this horse is favored to win this race. So if you see the odds like this, a probability is always measured not winning to losing, but how many ways could you win compared to the total possibilities. So for a probability, what I want to look at is the total number of races, for instance, or possibilities, and the number of ones we would predict would be winners. So for this horse, there's 2 wins out of 3 total races that the odds predict. So that's all you have to do to convert odds to a probability. This is just a fraction. You can go divide it. If you divide this on a calculator by hand, it comes out to be about 0.67. So that's 67%. So you have, roughly speaking, if you interpret these betting odds as the odds of the horse winning, the bettors who placed all the bets at the horse track that day thought there was a 67% chance this horse would win. Now, unfortunately, I don't remember who actually won the race, so I can't tell you if this was the correct winner or not. But compare this to the second horse, the one who was a little, well, he was considered less favorable to win. Apparently, the crowd didn't like this one as well. Those odds were 16 to 1. How would you compute the probability? Well, very similar. If 16 to 1, that means there's 17 races total. Out of those, the horse is predicted to win only 1. 1/17. If you divide that, well, I did it ahead of time on a calculator. It's only 5.9% odds, not very much. So if these were strict probabilities, what should happen is if I went down this list, computed every probability here, which wouldn't be too hard, they should total 100%. Because of the 7 horses, one of them is going to win. So if you find the percentage for each one, of course, it should total 100%. But I did this ahead of time, and guess what? This doesn't total 100%. In fact, it totaled over 120%. So how do you account for that? We have all 7 horses listed here. Well, of course, that's because the track is not playing completely what we would say fair. In other words, they're not paying you the same amount as the difficulty of winning the bet, but of course, they're keeping a little bit for themselves. So their computer systems, as the bets come in, they monitor the proportions of money going to each horse. They set these odds. These odds are purposely set a little bit in their favor. So their odds are kind of close to the percentage of money they received for each horse, but of course they're not exact because the track doesn't want to break even. They want it weighed a little bit in their favor. So what happens is, I totaled these up, and maybe they're keeping 18, 20, 22% or something like that for themselves. The rest, all the losers pay all the winners for each race, and all the money just changes hands. The track just keeps a little bit for themselves. You know what? It's fun anyway, even if you don't win the full amount you think you deserve. I suppose I shouldn't be promoting gambling here, right? You can go to the horse races and not gamble, and it's very fun also. It's a great track. It's beautiful. The crowds are interesting to watch, and the horses, of course, are very majestic running on the track. And I should say the Del Mar announcer is great to listen to. Now, we don't condone gambling here, but just for fun. So I was going to show you how difficult or how easy it is to get certain things that you might be playing and how they actually figured this out. So for example, I brought a deck of cards with me today, and just in case you're not familiar with cards, we're going to do a little bit of poker here. I know poker is really popular right now on some of the TV channels, And they usually play a game called Texas Hold'em. And those odds to figure out are a little more complicated. Actually on the show you'll see they show odds as the game progresses. So we're going to play it a little simpler here today. So we're going to play a 5-card stud, which means I'm going to deal you 5 cards and that's all you get. And we'll see what the odds are of getting certain hands. So for example, I have my cards here. I'm going to show you a certain hand that's kind of hard to get and will probably beat some of your friends if you were playing. This, I put them on my math cam here. This is called a flush. So this is 5 cards of the same suit. And if you look at these have little hearts on them. There's actually 4 different suits. So for example, this is a spade here, this is a diamond, and this is a club. So there are 4 different ones of those, and if you can get all 5 of your cards, all of the same suit, it's actually a pretty good hand. It's called a flush. So what we want to know is how hard is it to get one of these hands? It just dealt to you right off the bat. Well, you know, it's actually a little tricky to figure out the odds, but if you have a scientific calculator, there's a good chance it has a built-in feature that is made just to count things like this. It's called counting combinations. And so I have a nice calculator with me, and I'm going to show you, I'm going to use this built-in feature, and we can actually figure out the odds of getting a flush in poker pretty quick. So first of all, what we would need to know is how many ways are there for you just to get, in general, 5 different cards dealt to you. And so I'm going to show you how to do this on my calculator. If you have a different calculator, yours should be similar. Mine is a Texas Instruments TI-84 graphing calculator, but most scientific calculators have a similar feature. So there's this feature on my calculator, and it's called combinations. It looks like NCR here. And on my calculator, I got here by pushing a math button on the left, and then you see these little categories up the top, and I scrolled over to probability, which is PRB, and this is option number 3. Now if I do this, what we're going to do is I'll show you how this works. There are 52 cards in a deck, so I'm going to say out of 52, I'm going to choose, this is how you count how many combinations, I'm going to choose 5 of them. So this is going to count automatically for me how many ways there are for you to get 5 cards dealt to you. And I don't know if you can see that number. That is a big number. That's about 2.6 million. All right, so that's how many possible ways you could get cards dealt to you. Well, how many ways are going to turn out to be this nice flush? Well, I'll show you how we'll compute that. So what we want to think of is there are 4 different suits, and you're going to choose one of them. You want one of the 4. And then once you're there, you have to get all cards in that same suit. So what we're going to do is there's going to be 2 stages here. First thing I'm going to do is say, okay, of the 4 suits, I want to pick 1. So on my, using that same feature I just showed you, we're going to go ahead and say of 4 possible suits, we're going to choose 1. And for each of those suits, I'm going to multiply. There are 13 cards to choose from. So I'm going to, out of the 13 cards, I want to choose 5 of them. Now if I divide by the total number of possibilities, which is the same thing we did a moment ago with the 52 cards, then what we're going to do is we're going to compute how many ways are there to get what you want out of total number of possibilities. And the number we get is 0.0019. Now if you look at that, that's a probability, and normally that's, you can think of it as a percentage if you want. So if you multiply that by 100, that would be a 0.198% chance. That's not that great. I mean, that's like 0.2% chance that you're going to get a flush dealt to you. But it does happen occasionally, and if it does, well, you're probably going to beat your friends. Now there's a bunch of other poker hands, but maybe we'll save some of those for a future episode because they get a little more complicated. This one wasn't too bad to show you. I did want to show you, though, also playing the lottery, because some people like to do this in California here. We have our lottery. So I brought in a lottery ticket with me. I'm going to show you how this works, okay? So take away the cards for now. Here's my lottery ticket. And this is the California game called Super Lotto Plus. Now, the way this works is, I don't know if you can see them here. I have 1, 2, 3, 4, 5 numbers that I had to pick. Let's see, maybe I can get this a little closer for you. So I had to pick 5 numbers, 1, 2, 3, 4, 5, and then there's a 6th kind of bonus number they call a mega number. And the deal is if I match all 6 of those to what the lotto picks tonight, well, then I'm going to be very happy and very wealthy, and I'll be on vacation next week. So what are the odds of this happening? Well, I went to their official website, and they actually have the odds published there, but what I was going to show you is how do they get this. And if you use this built-in feature, it's actually not that hard. So let me show you on the web here. I brought my camera, my laptop. I have the official California Lotto page loaded up here. And if you look down, it actually has the odds. You can win if you match fewer of the numbers, but I want to match all of them, of course. So here we are. all 5 of 5 numbers and the mega number, and it says the odds are 1 in 41 million and some extra numbers there. So how did they get 41 million? Well, again, if you use this little built-in feature of your calculator, it's not that hard to figure out. So I'll show you how we're going to do it. So first thing we had was you had to pick 5 numbers from 1 to 47, and then we're going to pick a bonus number. And it turns out the only options for that are 1 to 27. So first let's concentrate on the 47. And so you're going to get your lottery ticket. You know, you're going to fill in your numbers. You have to fill in 5 numbers of 47. So on my calculator, I'm going to put in, just like we did with the poker hand, we're going to do, okay, so let's see, we had 47 options, and of those, I want to choose 5 of them. Now after that, I have to choose a bonus number, and there are 27 of those. So for each of these computations I have so far, I have 27 options for this bonus number. And so this is all I have to do, and if you look, that crazy number, that is exactly the same number that you saw on the web page. So 41 million to 1 are your odds of matching all those things. So I don't know, what do you think? You know those stories, right? You have a better chance of getting hit by lightning, or my favorite one, you have a better chance of getting hit by falling airplane parts. So there's something to look forward to. Okay, wait, I have one more. We have Keno. If you ever heard of a game called Keno, you can go to any casino, if you're old enough, in Las Vegas, or local casinos as well. We have local ones, and they usually play Keno. So Keno is similar to the lottery, so they have more options. So actually, I brought a little picture. I don't have an actual card with me, but I brought a little picture of what a Keno slip looks like. And there are 80 numbers on this, if you can see it. And you have to pick, well, you can actually pick as many of them as you want, up to 10 or 20. And then however many you match, well, that determines how much money you win. So what we're going to do is we're going to pick 10 of these numbers. And I actually have a Keno page loaded. This is from the state of Maryland, because Maryland actually runs a Keno game like lottery. You can go sit in a Denny's in Maryland and play Keno while you eat, if you really want to. So they have their payments printed here. So for example, on the left of the screen, it says 10-spot game. So this is, if you pick 10 numbers, what's going to happen is their computer's going to pick 20. And then depending on how many numbers you match is how much you win. So for example, right here, it says if you match 10 numbers, you win $100,000. This is only after playing just $1. You only have to bet $1 to do this. So I was going to show you how they got, or how the odds are for one of these. So I picked 8 here. So we're going to do the odds of getting 8 numbers matched, which would they pay you $400 for. And we're going to kind of judge, does $400, does that seem fair, or is that a little chintzy? So similar story, my calculator has that nice feature, so I'm going to use that. So here's how it's going to work. So this time, we have 2 different things to think about. The computer's going to pick 20 numbers, and you're going to pick 10, and you're trying to figure out, how many are going to match. So what we're going to do is I'm going to say, okay, of the 20 numbers that the computer picked, I want to match 8 of them. So using that same feature, we're going to say, out of the 20, I want you to choose 8 numbers that are going to match. Now, after that, I have 2 numbers that don't match. So that means out of the 60 numbers the computer didn't pick, I want to match 2 of them. And then I want to divide this by the total number of options. Out of the 80 numbers that could be chosen, I had to choose 10 of them. So when we do this all out, this computation, it says, well, this is a crazy number. That's 1.35 times 10 to the negative 4th. If I multiply that by 100, I'll give you the percentage. That's 0.0135%. That's pretty lousy. That's 1/100th% chance. So that tiny, tiny chance, they're only going to pay you $400. I thought that was a little chintzy. But I noticed something really interesting on their payout here. If you look back at my computer, you'll notice that if you match 7 numbers, they pay you $50. If you match 6, they pay you $10, 5, etc. But you notice that 1, 2, 3, 4 are missing. So if you match 4 numbers, they're not going to pay you anything. You're actually going to lose, which didn't seem fair because, hey, you matched some of them. But it turns out it's actually easier to match 2 or 3, for instance, than it is to match nothing at all. In fact, the weird part is if you look down here, if you pick 10 numbers and match 0, they actually pay you for $4 on your $1 bet. So I figured out the odds ahead of time. It turns out there's a, let's see, a 29% chance that you're going to match 2 of your 10 numbers, and only a 4.5% chance that you're going to match none. So it's actually easier to match 2 than it is to match none at all. So anyway, they've obviously had their math people work all this out and make sure that in the end, they're the ones making the money, not you. So there's your lesson for the day. It doesn't pay off to gamble. But if you want to do it for fun, for free, we can't condone you spending your money. And last week we actually discussed a little bit the odds of gambling. And there are a couple things on there I thought would be fun to pursue just a little bit. I showed you this game called Keno, and you can actually play this in casinos in Las Vegas, or I actually showed an example from the state of Maryland. They actually do it like a state lottery. But I brought a Keno card with me. So this is from the Luxor in Las Vegas. I'm going to show you, let's put this on my math cam here. This is an actual little slip you would see in the casino, and what you do is you'll see there's these numbers from 1 to 80 marked on here, and you would pick any of them, a number of these from 1 to 20. The example I did last week was you picked 10 numbers. So you would mark 10 numbers here, and then the computer at the casino will pick 20 random numbers, and depending on how many you match determines how much money you might win. And you can bet as much as you want. We did an example last week where you just paid $1 for the ticket. You just bet $1, and the idea was just to see what was going to happen. So interestingly, we did a couple of the computation of the odds, and they published the odds. So we were just kind of last week showing you, hey, here's how they got it. But one thing I thought of was, how do you know if they're paying you out at a good rate? You know what I mean? I mean, like, are they paying you a prize that's, worthy of how hard it is to get those numbers picked? So we're going to do a little sample here, and I'll show you how the casino might be benefiting from this versus how you might benefit from this. So I have a list here. We're going to stick this in here. This is a list from the Maryland Keno game where we choose 10 numbers, and if you match, how much they will pay you. So this was interesting from last week. If you match no numbers at all, they actually pay you, because it turns out it's harder to match nothing than it is to match 2 or 3 numbers. So if you match 1, 2, 3, or 4, they're not going to pay you anything. You lose your $1. From there, you can see here that if you match 5 numbers, it's $2. If you match 6 numbers, you win $10, etc. And if you match all 10, you get $100,000. Well, there's this concept called expected value, and this is a way to gauge how fair this is. And the idea is, if you sat in the casino all day long and placed dollar bet after dollar bet, and you played this thousands and thousands and thousands of times, on the average, how much could you expect to win back? So keep in mind, you're going to pay $1 for this ticket. So all you have to do is you simply multiply the probability by how much you would win if you get it. So the idea is, things that are harder to get, lower probability, but you get more money for it. So all we'd have to do is multiply all these probabilities by the amount you win all the way down this list, and when you total them up, you add them all up, that is the expected value. So I've done it on a calculator ahead of time. I didn't want you to have to watch me type in all these numbers. So on my calculator, I have this all typed in, all these multiplications. And if you look, what you'll see in the parentheses up top there, the 4, that's the amount you win, and the 0.0458 is the probability of getting that $4 win. And I even put the $0 wins in there just for completeness. So this is all 11 possibilities from 0 through 10. And if I add these up, it's going to tell me on the average what you would get back for spending $1. So here we go. I'm going to go ahead and do this computation. And if I typed all these in right, it says about 0.57. So what that means is you pay $1, and on the average, you're going to get 57 cents back on each dollar. That means the casino is keeping 43 cents. And you're probably not going to play this all day long, but they are. So in the long run, they're getting 43% of all the money bet on Keno, and they're paying 57% back out. It's not a very good deal, I don't think. So, people still do it because you might get lucky. It's like the lottery, but if you're going to gamble, which I should probably tell you not to, but if you're going to, the better games are roulette, craps, and maybe blackjack.